All right, we're back. We're still on page 178. We're working through some parabola problems. And now what we're going to do is we're going to try to find, what are we going to try? I guess equations of the parabolas, all possible, well, not all, but some of the possible parabolas that have a focus at 1, 1 and pass through the point negative 2, 5. So this problem is maybe more complicated than you're thinking. So the reason for that, I'm going to end up doing this on a separate page. So I don't know if you want to copy this here or whatever. It's up to you. The reason that it's more complicated than you might be thinking is that if this is 1, 1, right, that's the focus. And then negative 2, 5, I guess, would be kind of up here. So the first thing I need to know is the definition of a parabola. It's the set of all points in the plane that are equidistant from a point, which is the focus, and a line, which is the directrix. So the distance from the point to the focus, so this distance right here, which actually is, I'm never going to fit it. So let me move this to like here, I guess, and maybe move this a little bit. Where can you go that you're not in the way? Like maybe there. Okay. This distance right here. And what is this distance anyway? So it's 3 across, 4 up. So it's 5, 3, 4, 5. It's a right triangle. So this is 5. So the distance from the point to the focus, this is our focus, is the same as the distance from the point to the directrix, which means, am I gonna be able to do this? I'm gonna try to make a circle that has, I don't know how to do it. I want a circle that has a radius of 5. So let's say, I don't know what it's trying to do. It's trying to like snap it into place or something. Good-ish enough. Okay, so the distance from the point to the focus is the same as the distance from the point to the directrix, which means if I go 5 units up from the point, if I go 5 units up from the point, I will get one possible directrix. So there could be a directrix up here, and this directrix would be at y equals 10, right? Because we were at 5 and we went 5 units up. 5 plus 5 is going to give us 10. We could go down 5. And this would give us another possible directrix. This would be at y equals 0. Because the distance is still 5, we could go this way 5 units. This one, it's like pretty close, but like you can do it. This, so it's 5 units. This would be x equals 3, I guess. Something not right about my scale, but that's okay. Or we could go 5 units this way. So we can go 5 units in any direction. So there's actually, what would this be? X equals -7. There's actually 4 possible directrices. Each directrix gives us a different vertex. Each vertex directrix combo gives us a different parabola. There's actually an infinite number of them. I'm pretty sure I have another video about this where I like show kind of like moving it around. So we need to find each of these. And so what I'm going to do is I'm going to like copy this figure, I think, to another page and kind of work with it. Why will you not let me copy? Copy, and I'm going to paste it down here. So I was prepared. I knew this wasn't going to be enough space. Okay, so should I try to then use the same colors? I suppose. So parabola 1. So parabola 1. And this is going to open down. So this is the one that's kind of, I don't really know. It's opening down, right? Because the directrix, it's opening down because the directrix is up here and the focus is here. So where then, let's write what we know. We know the focus is going to be 1, 1, and the directrix is going to be y equals 10. Once you've used the point to find the possible directrices, you don't use the point again. Like it's kind of done. It's not the vertex. It's just a point that it goes through. So like when we check them, that would be useful. But for now, we don't so much need it. So like here, here. So there's going to be a point here. It's going to go like this, and then a point here and here. Just trying to orient myself. So the vertex is going to be at 10 plus 1 is 11, divided by 2 is 11 halves, or 5.5. I'm going to use 5.5. So the vertex is going to be at 1 comma 5.5. P is going to be the distance between the focus and the directrix is 9, and it's half of that, so 4.5. All right, so I'm going to write our equation. I'm going to write the equation and not like everything, because I think it's a little too much. So this will be y minus 5.5 equals, opening down, so negative 1 over 4 times 4.5 is 18, I think. It's 16 plus 2, right? So it should be 18. And x minus 1 squared. All right, that should do it. That should go through the point, negative 2, 5, have a focus at 1, 1. Maybe I should check that one before we go crazy and do the rest of them. So let's see if that fits the bill, right? So doc for new problem, graph, menu 3, 3, parabola, and then opened down, so we'll choose this. So negative 1 over 18, and then 1, and then negative 5.5. Negative 5.5? Oh no, 5.5. It's like how? Okay, so I'm gonna check some things. The focus is 1, 1. That's pretty good. And then I thought the directrix would be at 10, so I'll check that. Menu 6, 9. Directrix is, somewhere there, and then maybe y equals 10. Okay, so I mean, I'm pretty confident that we got that then. So let's go back and try another one. So I guess I'll do the one that opens up. So 4 options. It's actually an infinite number, but these are the ones that have like horizontal or vertical symmetry. So opens up, parabola 2. Parabola 2, you open up. All right, so we have a focus at 1, 1, and then directrix is y equals 0. So it's helpful. It's always helpful to kind of like sketch a little thing, right? So we're gonna have a vertex, it opens up, and here, if we wanted to find them, which I feel like I probably don't. So our vertex, the distance between 1, 1 and 0 is 1 half. So it's going to be at x is 1, y is 1 half. And then that makes p also 1 half. So this one's kind of small. Narrow, I guess, is what I mean. It's not going to be wide. No, it is wide. It's wide for 1 half. Yeah. Wider? I don't know. Kind of wider. All right, our equation. So it's going to be y minus 1 half equals positive 1 over 4 times 1 half is 2, x minus 1 squared. So let's check it. Let's see if it has the right focus and the right directrix. And then what I should really also do is somehow, how do I do that though? Let me try it. Can I trace this? Menu 5, enter, and then I need to trace to negative 2. Negative 2, 5, perfect, because it also needs to go through that. So doc for insert problem, graph page, menu. I could just change the one that I previously had, probably, and I think maybe, do I know how to change that? No, because I'm on the wrong like type, so I can't do that. No, I was on the right type. You know what? We're just gonna do it. It doesn't matter. Option 2, this, so it's gonna be 1 half x minus 1. Come on, 1. What are you? 1 half. All right, menu 6, 9. Focus should be at 1, 1, which it is. Directrix, menu 6, 9. Option 5 should be at 0, and I do not know why that keeps happening. I guess it's because of where I'm leaving the cursor. Y equals 0 is the directrix. You can barely see it. And then I'm going to trace menu 5, enter, -2, -2, 5. So it's working. All right. So I guess those are the things that we would really need to check. So I'm pretty confident. All right, let's move on to the ones that I screw up. So option 3, I'm going to say, is opens to the right. So parabola 3, I guess I'm calling it. Parabola 3 opens right. So if it's going to open right, then x equals -7 is its directrix. So focus. It's like you're always yelling that. Focus is at 1, 1, and then the directrix is x equals -7. This one feels like it's going to have, oh no, not really. I was thinking it was going to have like the worst values, but I think p is just going to be 4. So we're going to have this. It's going to be a vertex. So 1, 1, and x equals -7. So the -7 plus 1 is -6 divided by 2 is -3. So this is -3, 1. And that's our vertex. Okay, and then p is going to be 4, because you can go 4 in either direction from there. Okay, I think we're good to go. Let's not mess this up. So it's going to be x plus 3. It's opening to the right, so it's positive 1 over 4p, and then y minus 1 squared. And if we wanted to find them in points of the lattice rectum, focal width is 16, eccentricity is 1, like we know all these things. Let's check it. I like to check things. I mean, it's, first of all, if you've watched enough of these, you know that when I'm checking it, I might very well also have to change it because I get a lot of things wrong. So there's that. Eesh. That actually would have worked, I think, but like I do not want to do that. Well, this form. Okay, what do we need? So 1 over 16, 1, and then -3. All right, moments of truth. Menu 6, 9. Focus should be at 1, 1. Totally is. Menu 6, 9. The directrix, I think, should be at -7. Yes. And then I'm going to trace it. Menu 5, enter, and type. So there's actually 2, because this is not a function. There's actually 2 places when x is -2. Oh, what? When y is -2. So then do I type 5? Oh, interesting. It traces like it's a x is a function of y. So I put in y values and it tells me x values. That's pretty neat. I didn't know that was going to happen. But anyway, that worked. So let's go back and do the last one. And then there's actually one more problem on the previous page. Well, I mean, on the page that you might be writing this on. I knew, look at this. I was going to cram that in that little space. No way. Here we go. So, oh, I was supposed to underline that. Parabola number 4 is going to open to the left. So parabola 4. So don't forget, the key step, by the way, was creating this figure. And the key step of the key step was to find the distance between the point and the focus, because that tells you the distance between the point and each directrix. And once you know the directrix and the focus, you forget about the point. So I'm using it when I check, but like it's not involved in the process of solving. So like don't get lost there. So this is going to open left. It's got a focus at 1, 1 and a directrix somewhere. X equals 3. All right, x equals, so y right of 4, x equals 3. Here we go. So focus. So there's going to be a vertex in the middle. Perfect drawing. If we need these, they would be there. So 1, 1. So from 1 to 3, add them together, divide by 2, right? So you get 2, 1. 2, 1 is our vertex. And p is equal to 1, because if I go 1 in either direction. So we're opening to the left. So it's going to be x minus 2 equals -1 over 4p. and then y minus 1 squared. I think that's going to do it. So back to the calculator one last time, hopefully. Doc 4, enter, option 2, menu 3, 3, option 2. I want option 3. We go negative 1/4, 1, 2. Looks like it has a chance. Like you can tell immediately if you're very wrong, but if you're like kind of right, it's a little harder. Check the focus. Wait, what? Menu 6, no, 9. Oh, I think I found the vertex. I mean, that's clearly, yeah, okay. Focus is at 1, 1. Focus up, everybody. And then menu 6, 9, the directrix should be at 3, and it is. And then I'm going to try to trace menu 5, enter. I think that if I press 5, it's going to give me the point. Yeah, that's kind of neat. I hadn't realized that it like traces that way. So we did it. We got 4 of them. There's actually an infinite number, but we don't deal with symmetry over anything other than like horizontal and vertical lines. But like literally every possible directrix is somewhere on this circle. So like if you put a directrix here, there's a parabola for that. If you put a directrix here, there's a parabola for that. The only place there is not a parabola is if you try to put the directrix right here where the focus is on the circumference. That's not going to work. But literally every other point, it will work. And it's kind of neat. So that's that problem. And then write down the value or range of values for the eccentricities. All right, so a circle is a perfect circle. An ellipse is kind of like a circle, but is not. A parabola is always 1. It's like the dividing line between like sort of normal things and these insane hyperbolas. So this is just eccentricity is greater than 1. And that's that. All right. So we are done, which is pretty exciting because the next thing we're doing is moving on to the next set of notes. The next set of notes is incredible. It's parametric equations. I love it so much. I'll be back in that video to kick it off. So I will see you there.